Hey guys, good evening. So we'll be discussing the concept of min stack over here. I'll be starting soon. This is quite important for your interviews because it has frequently appeared on interviews. Uh, so let's start discussion in a couple of minutes after some of you join. Okay, so let us see how this works. What a min stack actually is, let us see. So min stack performs the or provides the following functionalities. A min stack has the following functionalities. Helps in the following. The first is add or push on the top, push an element on the top, just similar to an usual stack. Push an element on the top. Second is it will remove the top element, and you know that this particular operation is called pop, right? So these are three things, and a stack is defined in this manner. It goes from bottom to the top. So whatever is there over here, this is called the top, above which you have no other element. These are two usual things, and then you have read the top element, read or access the top element, right? These are three usual operations which any stack will perform. Now a min stack performs one additional operation. It tells us finds the or returns the minimum of all the elements currently present in the stack. Minimum of all the elements currently in stack. Okay, so that is a min stack. So basically it is something like this, that suppose you say that I want to push 3. So you have pushed 3. Then you say I want to push 5. Then you push 5. And then you ask what should be the min now. So it should return that the min is 3. Now if you say I want to push 2, it should push 2. Now you ask what is the min element, it should say that the min element is 2. Then you say I want to pop 2. So when it pops 2, after that when you ask what is the min element, it should again return 3. Okay? So at every moment it should be able to tell you what is the minimum element in the stack. So when you pop out certain element, it should consider that that element never existed. And whatever are existing currently, out of that you have to find out all the minimum elements. I hope this much makes sense from here. Any particular part do you not understand? I hope the first three operations you have done at least sometimes in some programs. You might have implemented stacks. And this is just a different concept where it turns out that finding out reaching the solution directly is not that intuitive, not that easy. So it is easier if you know the technique beforehand as to how we do it, and also it will be useful if you know how we reach that. Okay, but before we discuss techniques, what is there in your mind? It will be interesting to know. Suppose I don't tell you how I want you to do it. How will you do this? What should you implement or what should you use? What data structure, what algorithm should you use? And what will be the time complexity of the approaches? What do you think will be the time complexity and space complexity of any approach that you can think of to implement a min stack? Min stack will help in performing these functionalities. Any doubts regarding anything that I've mentioned till now? So let us discuss. The first thing is, whenever we have to implement these operations, let us do in the easy manner. And whenever we have to find the minimum, let us do in some manner like this. That will pop out all the elements and find out what is the minimum, and then we are going to store it back. So we are going to use some extra space. We are going to pop out all the elements and we are going to store it. So what is the time complexity? Then this minimum finding time complexity is order order n. In order to find the minimum, we need order n. And what is the total space complexity? You need order n extra space. So suppose this is the space which you are allowed to use, and apart from this, a single stack is what you are allowed to use. Apart from this, if you use an extra space, then you have to account for it. That extra space, what are you using? That is about n values. So it is order n. Okay. We want to reduce both of them. So what is the first thing that we can do? We can say something like this, that whenever we are storing elements in a stack, which is our usual stack, we can say let us update some main element stack where we say we find 5, so okay, the minimum till now is 5. Now we find 4, so the minimum till now is 4. Now we find 6, so the minimum till now is 6. Now we find maybe 5, so the minimum till now is going to be 4. Now we are deleting. Okay, sorry. So over here the minimum is 4, right? When you have inserted 6, the minimum is going to be 4. Now you say, now I want to introduce 3, and so the minimum is 3. Now you say I'll be popping 3. When you pop 3, you will also pop this, and now if you are asked after popping 3 what is the minimum, you will say okay, the top of the minimum array minimum stack is going to be the minimum, right? This is pretty intuitive. So every time whenever we'll introduce an element, we will see what is there on the top, and what can we say? That top represents the minimum of the currently available elements. So we can find out the minimum of the current element that we are inserting and the top element, and that will be the element which will be this particular thing. So we can say that this 3 came by performing the minimum operation over these two things, 3 and 4. So if we remove 3, then we'll basically get the previous minimum. So we'll be getting 4, right? So it makes sense, right, that we'll be getting 4 over here, and that is the minimum element till now. What is the time complexity is the main question to ask. So the time complexity turns out to be order 1. Why? Because every time what are we doing? We are basically performing either 2 pushes or 2 pops together, or we are saying we won't be performing any push or pop. If we use an extra stack, then the time complexity is going to be order 1. But the extra space that we are taking, that is again order n. Why? Because we have been allowed to use only a single stack, and now we are using an extra space, so it is basically order n. This is an extra space. Or you can say that we have been allowed to use store n elements, we are taking double space. However you express it, let's not go very theoretically into it, that it is less than equal to c times n, where c can be any constant, but basically the extra space is greater than n elements. But we want to see the entire storage to be only n elements. We don't want to store so many elements. I want you to use only one stack or one data structure by which you can perform these 4 operations. That is, you can add an element on the top, you can remove the top element, you can read the top element and find the minimum of all the elements currently present in stack. I am not asking you to remove the minimum element. I am asking you only find the minimum of all the elements currently present. Okay? Remove the minimum element is a different question, and that we find in heap. That removing the minimum element, that takes place in order 1 time. So something that the interviewer will not reveal is the complexities that he wants. He will leave that as a suspense, but I am telling you, I want these complexities: order 1, order 1, order 1, order 1, and again I want no extra space. I want just that simple stack which will store the values and only single values. I don't want something like this where I will basically store 2 things, 5, 5 and then 6, 5. So 6, 5 tells that 6 is the top element and 5 is the minimum element. I don't want something like this. It's the same thing as maintaining 2 stacks. I want you to maintain 1 stack, and I want you to, like, that stack should tell me at the same time what is the top element as well as what is the minimum element up to the top element. Okay, these are the two things that I want to. And also it should help in removing the top element and adding some element on the top. And the operations or the sequence of operations, I don't know. Queries are online, that is, the moment I get a query, I should be able to answer to that. I should not wait that, okay, let me get all the queries, I'll sort them in my efficient manner and then I'll be responding to it. No, the moment I get this query, I should immediately tell what is the minimum. What approach can we use? This is basically the central question. Any ideas? Okay, so let us do it in steps. First of all, let me give you a hint. Suppose all the elements are positive. So suppose all the elements are positive. All the elements of the stack are greater than 0. Now can you think of something? Now can you think of using the elements in some manner or storing the elements in such a manner that we can get the maximum element? Let us see that. So suppose these are our values. We have 5, we have got 3, we have got 12, we have got 4, we have got 2, we have got 6, and suppose we have got 1 and we have got 4. Okay, and now what I want you to do is, suppose these elements have been pushed and you need to tell me that what is the main element, then pop out the top element, then you tell me what is the main element now. So you basically have to push all these elements, then you need to tell me what is the main element now, then you pop this and then what is the main element, pop this, what is the main element, pop this, what is the main element, and so on. We know easy solution is priority queue or heap. If this is the sequence of operations. No, we know that if we store this and if we use a red black tree together with it, that is going to be a very easy approach. Red black tree, or maybe you can try tree set or your C++ set. That will tell us what is the minimum element and we can do a lot of things. But the time complexity is order n log n. I want you to stay in order n only. Order 1 per operation, not order log n per operation. Okay. So what can we try? We can say something like this. That first I am putting 5 over here. 5 is at the top. Okay. And what is the minimum element? The minimum element is something like 5. Then I say I'll be putting 3 over here and the minimum element is 3. I know 3 is the minimum element. And for all of them I don't want to perform this particular thing. What thing? For all of them I don't want to perform this storage, that up to here this is the minimum element. So first of all I want you to observe something. Let's have a look at the trend. 4 we have 3 over here, then 2 we have got 2 over here, then 6 we have got 2 over here. These are the minimum elements up to this part, right? Then we have 1, we are getting 1 over here, and then 4 we'll be getting 1 over here. So observe this. Observe the points where this changes. Go from this direction to this, like this, left to right, and observe where it is changing. You can see it is changing here from 5 to 3, then from 3 to 2 it is changing here, then from 2 to 1 it is changing here. Can you see something very interesting? And the interesting part is whenever it is changing, it is having exactly this element, right? It is having exactly this element. So the top element is equal to the minimum element at the point where it is changing, right? So from here I can say one thing, that if I store the minimum values, I'm going to lose these values like 12 and 4. I'm going to lose these values for sure. But if I store the minimum values, I can say this 3 will help me get this one. So if I have this 3, I'll be able to get this 3, so I don't have to store this thing. and I can utilize it to store my previous minimum or previous values maybe, right? So I know, suppose I stored the minimum. Try to capture the idea. When I'm storing the minimum, I know that when this minimum is changing from 5 to 3, keeping this 3 is redundant. I don't require this 3. Rather, I can say instead of this 3, I can have an indicator that after popping this 3 from here, I'll be having 5 over here. Okay? I'll be having some 5 over here. Or maybe I can keep an indicator stating that whatever you are having as main element, that is going to change now. So observe me and understand what is going to be the previous minimum element. This is the idea we'll be applying. So what can we say? Let us try to do just the single thing, that we'll be replacing these things because they are not required by the previous minimum. Let us see what we can do. We can say that all the numbers are greater than 0. So our indicator should be something that if we have something like x over here, we should be able to understand seeing that x that it is an indicator. It is not a normal element. We see 5, 3, 12, 4, 2, 6, 1, 4. These are normal elements. But when I see an indicator, I should understand it is an indicator. The normal element is located over here. And this is an indicator which gives me some information about the previous element or previous minimum, whatever. So what can be the property of this element? Since I know that all these elements are greater than 0, what can I say? That if I use some indicator which is negative, automatically that is going to indicate what? That is going to indicate that is an indicator. If I have any negative value, suppose minus 8, I'll understand this is not a normal element because in my constraint it is given that all the elements are greater than 0. So if I keep a negative element which indicates something, I don't know what, I can understand, okay, that is an indicator, let me try to understand that. Now what can I say? I can say this, that okay, if I use this indicator as minus 5 or minus of this particular element, from here can I get this particular element? We can get, right? Now let me know if you can hear me first of all, because I have not been getting responses. So can you hear me? Are you understanding this? Else it is pointless to move on because I am not accustomed to, like when I sit with the mindset of a recorded lecture, I proceed in that way. When I sit for live sessions, I want the atmosphere of live session. So let me know if you're understanding this. At least a single student? Or is it totally, escaping? Like till now, are you able to hear me, or are you like just there is no other video to watch hence you have just come over here? Okay, fine. So there is one response. I hope the rest are also able to hear me. And I hope you are understanding something. So this is the idea. Similarly for this, what can I say? Instead of 2, I can place something like minus 3. What minus 3 indicates is this is an indicator. This indicates that the previous minimum is going to be 3. And when I see this indicator, I also understand that the minimum is changing over here. If the minimum is changing over here, I know that the current element is equal to the current minimum. Right? Current element is equal to the current minimum. Please keep on responding so that the flow can be much better. Okay. Because it is not a physical class and that is disadvantageous for all of us. For all the serious educators and for all the serious students, it's always a disadvantage. But anyway, let's not start the old folklore, but let's first guarantee that you all can understand something, or basically, the things are proper, whatever it is, whatever lines I'm mentioning, they're making sense. Okay, cool. So the same thing I'm going to apply over here. I'm going to say that I'll be placing -2 over here. When I place this -2, I come to know that the indicator states that this is changing, the minimum is changing over here. If the minimum is changing, then I can say that the current element is going to be 1. Instead of looking at this set of current elements, I can state that the current element is 1, and from there I can also state that this is -2. This means that the previous minimum is going to be 2. Why? Because -2 indicates that elements were supposed to be positive. Since it is negative, it is referring to the previous element. Makes absolute sense? So how can we store it? Now let us see what we can do. We can do something like this. Now I can say, suppose I don't have all of these things. Suppose I don't have all of these things. Rather I have something like this. I have 5 and then this -5. Then I've got 12, 4 and then this -3. Okay. And then I've got 6 and I've got -2 and 4. Now what can I say? Let me just imagine that I have got this particular thing over here, 1. Let me see whether I can generate this back. Okay, and let me see whether I can answer all the principal questions, that what is the top element, what is the whether I can remove the top element, and after removing whether I can get the minimum element always. So I have only this much. What I'm saying is I won't be having this part. Okay, now this is not equal to my initial array, but I have to operate in terms of my initial array. So when I say I want the minimum element now, I want the minimum element among these elements. So while storing this element, suppose I've stored in this manner. Let me see what happens then. When I've stored this 4, or for this last element 4, I'm having 1 over here. What does this indicate? That the minimum element is 1. So if you ask me what is the top element, I'll say 4. If you ask me what is the minimum element, I'll say 1. And both are correct. Now I'll say that it is not an indicator, it is not negative. That means the minimum is not changing. So can I directly say that, okay, that means the minimum is going to be the same. It is going to be the same over here. It's going to be 1. It is going to be 1 over here. What is the next thing I can say? That now if I ask you what is the minimum element and what is the top element, what can you say? It is an indicator. What does that mean? It is an indicator. That means this is the minimum element and this is the top element. So the top element is the minimum element. So if this escapes, then the minimum is going to change. If this is removed, the minimum is going to change. So we can say the top element is also 1 and the minimum is also 1. Right? Cool. So now what can we say? Now we are going to remove this element, and what are we going to have? What is the new minimum going to be? We can derive it from here. We can say -2 indicates that the previous minimum was 2. So we can have something like this. When we remove this, we have 6 and we have 2. Now 6 is a normal element. It is not an indicator. So what can I say? The top element is 6 and the minimum is 2. Whichever you ask, I'll be able to tell you that. Similarly, now what can I say? What will be the minimum up to the previous one? Suppose I pop out 6. What will be the minimum? I can say there's a normal element. Normal element means minimum is not changing over here. So I can say here also the minimum is going to be the same. It is going to be 2. Right? And now after popping out 6, if you ask me what is the top and the minimum element, what can I say? The minimum element is 2. I've got this. What is the top element? This is an indicator. The indicator means the top element will be exactly equal to the minimum element. So this is 2. And then what can I say? This is an indicator. This indicates that I'll have minimum element 3 over here, right? We'll have minimum element 3 over here. So 4 is the top element, 3 is the minimum element. We'll have 4, 3. Then there's a normal element, so this minimum remains the same. It is 3. So the top element is now 12 and it is 3. After popping out, we are getting this. So it is 12, 3. And then we have -5. First of all, this is a normal element, so the minimum is going to continue. So we have got this 3. So -5 and 3. 3 is going to be the top element because this is an indicator. So we have got 3 over here and 3 over here. And what can we say? This is going to indicate that the previous minimum is going to be 5. So can I say now also I have the correct values? 5, 5. So see, I'm able to regenerate these values and the lower values as well. 5, 3, 12, 4, 2, 6, 1, 4. 5, 3, 12, 4, 2, 6, 1, 4. Do you get it? We are able to regenerate it even after storing this scrap. From here I'm able to regenerate this. After storing this scrap, a very different derivation of the original sequence, I'm able to get back this. And what did I have? I started with only these values and I had only this value with me. With only these values, I'm able to generate all these values. I'm able to generate all these values and I'm able to generate all these values. Okay? At every point of time, I'm saying just store the minimum element till now, and this derived or transformed kind of a stack sequence. And from here we can do all these functionalities of main stack, given that all the elements are positive. Let me know if you're understanding this and let me know if it is clear up to here. Then we'll be proceeding. Do you want me to code it? Do you want me to code it and show that it is going to work? Our response would be nice, guys. I know it has been shifted soon. I know it was not pre-informed, so you all came at a very sudden notification maybe. But are you all understanding it? Otherwise it is really pointless because I know these things. Why should I speak all these things? Okay. That's nice, Manas, and I hope you have liked the approach, though it was very easy. But now if I suppose change this particular consideration, which is all elements may not be positive. Elements may be negative, maybe 0, maybe anything. So suppose that elements can be anything. AI can be anything, any integer. Okay. So in that case, what should we apply? How should we proceed? Think over it a bit. What did we use? We were using a property that our current element or current top element is ideally supposed to be greater than 0, and we are hence creating a contradiction or creating a kind of exception over there in order to indicate the previous value. There are two things to be observed. First of all, a perfect indicator, an indicator which is very well defined, and also it is defined in a different manner. The indicator helps me deterministically understand what is the previous value. So there is a very distinct formula, which is whatever is the indicator, just negate that, just take the negative of that, and we will get the previous minimum. So it was a pretty deterministic workflow, right? And I want a similar thing for the current stage. Now all the elements can be positive and can be any values. So what value will tell me that this element is wrong? I only know one thing. Think in the same manner. Now I know only one thing. Suppose I have x over here, and suppose I have got y over here. What is the only thing I know? Do I know this? Y is less than x. Sorry, less than equal to x. This must hold. So if in the original sequence, this is my original sequence. Guys, respond if you are understanding this. This is my original sequence and these are my main elements. This is my main element till now. So this will tell me what is the main element in this particular range. So if I know y is the main element in this particular range, I can say y is less than or equal to x. And if it is so, I can say that if I replace x by something which is less than y, suppose I replace x by z. If I replace x by z such that z is greater than, y is greater than z, what can I say? Greater than z, what can I say? That is, z is going to be basically an indicator. I cannot have an element which is 3 over n and I will say that okay, the minimum up to here is 4. Okay, I'll explain this. So what I'm saying is, you can have something like this, right? That up to here the elements are maybe up to 3. You can say the minimum element can be 2, the minimum element can be 3, the minimum element can be 1. But can you say that the minimum element up to here can be 4? You cannot say, right? So I hope this is the explanation you are wanting and not the previous one. I hope you have understood the previous one to some extent. The previous one we have just used, basic idea, negatives and all. So here what we are saying is this particular element, whichever is the minimum, that must be less than or equal to x. It cannot be like this. Like the lower element cannot be bigger than the upper element, right? So if we use this kind of an indicator z, which will be greater than this element, which will be lesser than this element, according to this, z will be lesser than y, then what can we say? That from here I will understand this is an indicator, and this indicator will again indicate the same thing, that there is a change of minimum occurring. So when I know a change of minimum is occurring, suppose from maybe y dash to y, what can I say? I will use an indicator which should be less than y, which will tell me in the first place that it is an indicator, and also I should be able to obtain y dash from it. Make sense? I should be able to obtain y dash from it. So this is the first thing that we identify. According to our previous approach, if we emulate our previous approach, this is the modified thing that we should be doing. This is our modified condition. Over there we had a different condition, that whatever we'll be placing, that a, if we call that value, a should be less than 0 or less than or equal to 0 maybe. Here the modified condition is we should be placing something which is less than the minimum. How can we create such a value? How can we create a combination of y dash and y dash and y, such that this element is always less than y and this has a one-to-one mapping with y dash. If I change this value, y dash is going to change. If I change y dash, that value is going to change. And if I know f of y dash comma y, I can find out y dash using the value of y, because I know what is y, right? So over here, what I said was, I know 12, I know 3, I know minus 5, I know 3. I don't require to know 3. I can say that from minus 5, I can directly derive 5. So here this is like f of I to me. From f of I can get I. Similarly, I'm looking for something like this. Suppose this one is y dash. Then minus 5 was basically minus y dash, which we can say this was f of y dash. So here the function was that f of y dash equals to minus y dash. Right. Similarly, now I'm looking for some function so that if I know what is my current element, suppose it is z and suppose it is y, and if I know z is nothing but f of y dash comma y, then first of all this value has to be lesser than y in order to indicate that this is an indicator, and from here I should be getting y dash. Okay, I should be getting y dash. So what should be the way? What should we apply over here? Or what can be a function which deterministically tells us that any function will be correct if it is like if it follows the correct mathematics? A linear combination, a quadratic combination, whatever you choose. But it should be easy to calculate this from here to here. You cannot choose some kind of hashing or some kind of whatever. You cannot choose anything just arbitrarily. It should be easy to obtain. You cannot choose any cryptographical such measures that it's a difficult problem in itself to find out y dash from f of y dash and y. this has to be less than y. What do we know about y dash and y? We know this particular y dash, what will happen? If it changes, that means it is increasing. Can I say that this is increasing in this direction? Why? Because this was even a lesser minimum. So if it is changing, that means y dash is less than minimum. Y dash is less than, y dash is greater than y. It is increasing in this direction. This is even a greater, better minimum that we got, right? So what can we say? If it increased in this direction, that means, can we say we require something which is less than y? So first of all, y minus y dash is less than 0. So we have obtained something which is less than 0. So if I know that y is positive, I know that, okay, if it is less than 0, that means it will be less than y, if y is positive, okay? But I don't know if y is positive. Y can be minus 100 as well. So y minus y dash will be less than 0, but it may not be less than minus 100. So from here, can we derive some other linear combination which will be less than y? Can we say just add y to both sides? So what do we get? 2y minus y dash. That will be less than y, right? So can we say that if we store 2y minus y dash instead of the value of y over here, when I know that this is y and before this everything is going to change, instead of this I'll be storing 2y minus y dash. What do I know? Y is less than y dash. Y dash is the previous minimum. Now the minimum got better, it became lesser. So what can I say? 2y minus y dash will be lesser than y. 2y minus y dash will be lesser than y. Simple reason, because y minus y dash is lesser than 0. So I can say this is an indicator, and from this, suppose this is z. You know that this is z. How can you find out y dash from z? You can say something like this. Y dash is nothing but y dash is equal to 2y minus z. And how are you finding this y? You know already y. You know already y. So you have, basically this is how it looks like. You have some element over here. Just a second. Yeah. You have z over here, you have y over here, and you have y dash over here, which you don't know. You have to find out y dash. And you know if z is actually less than y. If z is less than y, then actually this means that z has been formed by 2y minus y dash. So we can find out y dash by this 2y minus z. So we can see that the lesser, the previous minimum is going to be 2y minus z. Okay. And from here, what can we do? Again, we can say the same thing. So let us apply this on a problem and let us understand it better. It will be nice if you can convey that you have understood something, because it is a slightly advanced computation, but I have tried to explain it in the most deterministic manner, so that it's most logical. Okay, so that you understand what is actually happening. Why is it happening that way? So anyway, let us take it 3, and suppose this is 5, and suppose now it is minus 2, and now it became 4, and then it became 3, and then it became minus 6, and now it became minus 1, and now it became minus 4, and suppose, okay, up to here, fine. Now we'll be storing it in this manner. We'll be storing everything and in this manner. 3, 5, minus, instead of minus 2, okay. So 3, 5, let me first store this, 2, 4, 3, minus 6, minus 1, minus 4. Or let us do it from the beginning. We know 3, and we know up to here the minimum is 3. Now we know it is becoming 5, but the minimum is not changing. So keep it 5 and keep it 3. Okay. Now when you will keep this 3, this is gone. You are not storing this. You are only storing the last value. Clear? After this, you basically have minus 2. So when you have minus 2, you'll be placing minus 2 as the min. When you have minus 2 as the min, no need to place minus 2 once again over here. Try to place something like this. 2y minus y dash. So it will be 2 into minus 2 minus 3. So it will be minus 4 minus 3, which is minus 7. Then we can say we are getting 4 over here. 4 is not the minimum, so we will place 4 and we will have this as same. So see, when we are using the indicator, when this changed, once again the same observation. And now we will say, let us write down for 4, we have the next element 3 and the minimum is say -2. The next element is -6 and we understand that the minimum is going to be -6. So there is no use of this -6. Let us replace it and we can say that we are going to replace it by something like this: 2 into -6 minus -2. So it is -12 plus 2, which is -10. So I'll be having -10 over here. So you can see for all these elements, what am I having? This element is less than this element. This element is less than this element, right? So I can directly say that we are understanding in order one step, or in rather only one step, that this is an indicator element. This is not a normal element. This is an indicator element. Then we go to the next step and we say -1 is going to come. So -1, place it. And the minimum remains the same. Then -4 is going to come, place it. -6 is going to remain the same. Okay, this is how we are forming it. Now understand this, that we won't be storing all these things. We'll be deleting all of these things. Okay, we'll not be storing anything like those brackets also. This is the only thing that we'll be having. We have this one stack and we have one minimum value. And we have to generate back this entire thing, or basically using this, whatever we could have done, we have to do everything like that. So let us say when we have this at the last step, what can we say? Using this, I can say that the top element is going to be -4 and the minimum element till now is -6. Now I tell you, okay, pop the element, pop the top element. So if you pop the top element, what can we say? If you pop the top element, we will remove this. And on removing this, I know this is not an indicator element. Why? Because it's less than or equal to this one. Sorry, it is greater than or equal to this one. This is the minimum element, greater than or equal to minimum. So it is not the indicator. So we will know that, okay, this is the same. The minimum will remain the same over here. You have the minimum same over here. You have left the minimum unchanged. Now again, it's the same thing. If I'm asked about the top, I'll say it is -1. If I'm asked about the minimum, I'll say it is -6. Then you say, okay, the top is greater than or equal, so it is normal. I'll have the minimum continued. Now I see that this particular element is lesser than this, lesser than the minimum. It cannot happen ever. That the current element is lesser than the minimum element, it cannot happen. So I know this is an indicator. From here, what will I say? That what is the current element? If I'm asked what is the top element, I'll be performing 2 into this minus this. So I'll be performing something like this: 2 into -6 minus -10. So what will I get? -12 plus 10. So it is -2. So I can say it is going to be -2 over here. And we can understand up to 3, -2 is only the minimum element that is formed. So see, we had deleted -2. We had no knowledge of the previous element, but we can generate this -2 right from here. We know that the top is the top is not -2, rather we can say from the top we are getting this value. What is the top? When it is an indicator, the top is exactly what is the minimum element. Whenever it is an indicator, it indicates that the top is the main element only. So here we will say that the top element is going to be -6 and the min element is also -6. But this top element is going to tell us what is the previous minimum. Okay, now we see this is again normal element, so we'll copy this. It is -2. Again, this is normal element, greater than or equal. We'll copy this -2. Same thing. Okay, over here we see that it is again lesser. So it indicates that it is an indicator. Indicator means the top is going to be -2. The min is going to be -2. And we can check when 3 elements are present, the top is also -2, the min is also -2. Can you see this? So it gives us the correct information. Now we want to find out this minimum element. How can we find out? 2 into -7 minus -2. So we can say -14 plus 2 is -12. Just a second, I think some calculation mistake. 2 into -7 is okay, I'm sorry. So 2 into -2. 2 into -2 minus -7. You can see that is what we were doing. 2 into this element, minimum element, minus the top element. So it is -4 plus 7, so it is I think +3. So if you use plus 3, what can we say? This minimum element will be minus 3. We can check this is the minimum element in this particular range, and the top element is also correct. So we are getting the correct values. So now also you can see there's a normal element, 3 is less than equal to 5, so we will copy down 3 over here. Again 3 is the top and the minimum element, so it's a fine. Right, makes sense? Any questions? Do you want me to explain any part again? Usually in the first step it's a bit difficult to understand, so you can ask me any question on any part. We can go over that. So okay, maybe we can try implementing it. Since some of you may wait for the coding implementation, it's going to be very like there is nothing like that. I don't think I have any folder on stacks. So this is what I'll be doing. Touch minstack.cpp, and I'll be opening that minstack. Yeah, let us copy from my template to this file so that at least I have some template. I don't have to write everything from scratch. Okay, sorry. Int main, and what can we say? lln, cn. These are all the operations, okay? And I'll be simulating this using a vector. Using a vector, I'll be simulating. Vector pushback means pushing at the end. Vector popback means popping from the end. So I'll be using a vector v to simulate this. And what shall I say now? Okay. For LLI equals 0, I less than n, this is a number of operations. And I know the minimum value LL main till now is going to be something like a very large value, 9999, something like this. Okay. Okay. So as we'll proceed, we'll do something like this. We'll be taking two integers a and b. The first one will say or suppose we'll take one integer, and then if the first one is, if a equals to 0, that means we have to print out the top element. Okay, we have to print the top element, or suppose we have to push something, so we have to index some number. So push operation is the first operation. We'll be pushing the c in b. Okay, and then we will say what we'll be doing with this, pushback b, we'll be pushing this. Else if a equals to 1, suppose we'll be popping it. If you have to pop it, okay, we don't have to read anything. V dot pop back is going to do the operation for us. Okay, if you can say if v dot size is going to be greater than 0. I hope this makes sense. And then we'll be saying else if a equals to 2, then tell me what will be the top element. So we will do something like this. Top element, yeah, we are just going to print this for a normal stack. We'll just be printing what is v of v dot size minus 1. And once again you have the same thing. You have the same thing, that if v is greater than 0, then only we'll be doing it. Okay. And what else? Else the last option is that we have to do the minimum. So now let us implement the main stack. So for the main stack, we have an initial minimum, which is this. So when we introduce something, our minimum can actually update. So if our minimum is less than equal to b, then we will say silently do this, the minimum remains unchanged. If it is not the case, then do something like this. If you know that B is less than the minimum, that means you have to update the minimum. So you say now minimum is going to become B, and what should we store? V dot push, or V dot push back PB. Let us see what we were doing. We did something like this: 2 times the minimum element minus how did we store it? How did we store minus 10? We said 2 times the new minimum minus the previous minimum. So 2 times B minus min. So we'll do something like this: 2 times B minus min. I know this will be less than B, because B minus min is less than 0. And I'll say now min is going to be my B. Okay. Now I see if I have to read the top element, then there are 2 things. If V dot size is the first thing, then there are 2 things. One is if I know that, suppose this particular top, it is nothing but width. So when we are popping the top element, we have to regenerate the previous minimum. That is the only operation that we are left with. In order to regenerate it, what do we know? 2 times the minimum element minus the current element. That is the case. But when will we do it? If V of V dot size minus 1, I think we can do something with this. We can copy this, that LL element, whatever we are having at the top, this is equal to this. So what can we say? If this element is less than, the minimum element, which is min, then we have to update it. So how will we update it? Min is equal to 2 into min minus element, and then we can do that single thing, V dot pop back. Okay, that is common for both the cases. Makes sense? And if it is like only about printing the top element, then also there are 2 cases. The first case is, I think we can store this. Okay, and we can say if the element is less than min, then the top element is going to be min itself. So we are going to print only the minimum element. Okay, and else we can say, else the top element is going to be nothing but the element that we have read, the top element. Okay. And what if we have to read the minimum element? If we have to just read the minimum element, we can say it is nothing but that which is located in front of you, and okay. These are going to be our operations, and let us see. And let us keep track of what we are doing. G++ min stack. Let us do that kind of an operation. Now you can say I'm maintaining only one stack. Now what will I say? First enter the numbers. So use okay, 0, 1, 2. Okay, using 0 I'll be entering the numbers. How many operations first I have to state? Suppose there are suppose there are 20 operations or 16 operations, suppose, and I'll be entering the numbers first. Let us enter these numbers: 3, 5, minus 2, 4, 3, minus 6. Okay, 3, 5, minus 2, 4, 3, minus 6. These are my 6 number. Okay, I'll be entering these 6 numbers. So I think we can comment it somewhere over here. 3, 5, minus 2, 4, 3, minus 6. Okay, I'll be entering them one by one. So 0, 3, 0, 5, 0, minus 2, 0, 4, 0, 3, 0, minus 6. These are the numbers. Okay, I've entered this. So now if I ask what is the top element, what is it going to tell me? The top element is going to be, if I say just 2, what is the top element? It should be 6. It returns, sorry, it should be minus 6. It returns minus 6. If I ask it what is the min element, then also it should be minus 6. So I'll ask 3 and it returns minus 6. Now I'll say pop the last element. If it pops the last element, it will do something like this. I have to send 1. So I say pop the last element. When I pop the last element, what does the set become? What does the stack become? 3, 5, minus 2, 4, 3, right? So up to here, we'll be displaying what are the min elements and the top elements. So let us first print the top element. What is the top element? The top element is 3. And what is the main element? It is minus 2. So the top element is 3 and the main element is minus 2. See, both the information have correctly come in front of us. Now what else can we say? Now let us pop this 3 as well. So this will be popping using 1. Now what do we have? We'll be having 3, 5, minus 2, 4. 3, 5, minus 2, 4. What is the top element and main element? Top element is 4, main element is minus 2. So we'll be having something like this. Top element is 4, main element is minus 2. Now we'll be popping this. We'll be popping this using 1. And now we will say we have only these elements left. 3, 5, minus 2. Now both these operations 2 and 3 are going to return me the same element. This is the minimum and this is the top, 2. So I can write 2, I am going to get minus 2, and similarly with 3 also we could have got minus 3 had we done more than 16 operations. So this is actually the code. You can see it's pretty easy to implement, to remember, but it's not that trivial to come up with. But you can see how we logically came up with this approach. And we showed that this is always going to return or going to give all these applications, serve all these applications in order one time. Make sense? So today we discussed a very important problem in the perspective or in interview perspective for basically placements and sometimes for internships. We discussed how we can form a data structure which can do all these operations in order one time and also maintaining no extra space compared to stacks. And we then saw first using an assumption all elements are greater than 0. Then then doing away with that assumption. We said we will not take that assumption and then we again solve the problem. So that's it about today. And I've not introduced myself. I'm Saptarshi Mukharjee. I'm an educator at Unacademy. I'm a 6-star rated coder at CodeChef and I am a master at Codeforces. I've been a master at Codeforces. I've been to the ACM ICPC regionals in 2019 and I'm going to join Google quite soon. So that's about myself. I hope you enjoyed the session. Very quickly, I will tell you about the batches which are going to be offered at Unacademy so that you remain updated. Okay. It's going to take just 1 or 2 minutes. If you have any question about the problems or about the batches, you can ask me. It's going to take about 1-2 minutes. You have these 4 batches: Transpire, Eklavya 3.0, Brahmastra 3.0 and Mahayuddha. Transpire is for CS fundamentals. Eklavya is for beginners, from beginner to advanced. All these topics will be covered in 7.5 months. And you have Brahmastra, which is for college and off-campus placements. And Mahayuddha is only for advanced programming. I'm taking this batch. So you have these 4 batches. You have a structured learning path, 1 subscription on unlimited access, best coders of India, and all these things. Then Transpire basically covers all these things: networking, DBMS, RDBMS, operating systems, and object-oriented programming. Okay. Then you have Eklavya structure, something like this. It starts with beginner level topics, then we then with intermediate topics, and then it proceeds to the advanced topics. Then the Brahmastra, which basically covers all the interview related aspects which are covered in the interviews. And at the last 2 weeks, you have interview problems asked in FAN. And then you have Mahayuddha 2.0, where only the advanced topics are going to be being covered. I'm taking these courses now. You have advanced dynamic programming, you have segment trees, advanced concepts of graph theory, and mixed problem solving. These are some of the educators. You have ICPC World Finalist, Codeforce Grandmasters, alumni top prior companies, and you have live interactive classes, practice relevant problems, doubt support, and yeah, this is the plan: 1 month 6,000, 12 months 33,000. It is quite discounted, so you can think about it. And if you use my referral code, you can get an extra 10% off on top of these prices. So you can think about that. Okay. You can take my referral code. With this referral code, you can attend all the special classes for free, and you can take the plus subscription with that discount, extra 10%. And it will also enable you to visit all the batches, not only my courses. It will help you to visit all the batches. So that's it. We are on time, and any questions if you have, you can ask me, as we'll wrap up here. Last 30 seconds. If you have any questions, you can ask me. Okay, then take care, guys. Good luck with all your endeavor. Hope you can utilize these things, these tricks, and these concepts in your placements. And hope you all have very good placements. So let's call it a day. Have a nice evening.